All right, students. So today we're going to talk about the rock cycle. All right, and bear in mind for me that any cycle will actually have multiple processes and whatnot at play. All right, students, the rock cycle aims to explain the creation, the alteration, and also the destruction of rocks. All right, just like everything can be created, everything can be altered at some point, and also everything can be destroyed. All right. As we can see on this diagram, we have certain processes and whatnot at work. For example, this volcanic activity can actually help in terms of the creation as well as the destruction of rocks. For example, this same molten materials, which are in fact rising onto the surface, these molten materials, in this case lava, would tend to officially cool and solidify. And as a result of that, students, that cooling and solidification will result in solid rock structures to eventually be formed. But if I were to tell you this volcanic eruption was in fact very explosive, all right, for instance, Krakatoa, and many other volcanoes in the past, all right, because of the amount of smoke created, the ash and whatnot, the pulverization of the rocks would surround the cone. That would exemplify the destruction of it, the destruction of the cone. All right, look at this particular image on your screen. This is a volcanic cone, and wait for it, this is an explosion. All right, this explosion can actually be significant enough to simply disassociate existing rocks, all right, into smaller particulates or pieces. All right, this is an explosive volcanic eruption. Okay, so volcanic eruptions can, in fact, destroy rocks into smaller pieces or smaller fragments. This is, in fact, Krakatoa in the year 2018. All right, Anak Krakatoa to be specific. And this was, in fact, very pertinent, primarily because in 1883, this particular volcano, Krakatoa, that is, not the exact same thing, but it's responsible for literally blowing off the entire cone, all right, from the surface of the Earth. Now, students, when we can take into consideration, when you take into consideration the destruction of rocks, all right, how can rocks be destroyed? We can conceptualize natural processes as well as anthropogenic or man-induced activities. For example, everybody know human beings can detonate bombs, whether it be nuclear bombs all the way down to simple dynamite and whatnot, and also use heavy machinery to break apart rocks into smaller pieces. But naturally, volcanic eruptions are in fact the main constructs which can be associated with the disintegration of rocks. Also, the earthquakes, the shifting of plates, all right, can be associated with rocks or surface solid materials to become fragmented. In terms of natural processes, weathering and erosion can be associated with the natural breakdown of existing consolidated rock structures, and they can eventually be subjected to transport and redeposition elsewhere. All right. To highlight something very quickly, rocks can also be created. We also indicated volcanic eruption here at divergent or even at convergent plate boundaries, and also the alteration of rocks. Now, students, the alteration of rocks, this is in fact associated with extreme or immense pressure and immense heat. And this is primarily associated with deep areas, primarily deep below the volcanic cones, in relatively close proximity to the magma chamber and also to molten materials within the mantle. Now, there are three main classifications, or if I were to say categories of rocks. We have igneous rocks, sedimentary rocks, and also metamorphic rocks. All right, students, igneous, the word igneous comes from a Latin word ignis, and this simply means fire. And in terms of the Earth, volcanic environments are in fact associated with a significant amount of heat, which can produce fire, especially if you have combustible materials close by. Now, igneous rocks can be subcategorized into two. We have intrusive igneous rocks, and we also have extrusive igneous rocks. Now, class, look at the term itself. Intrusive, IN, all right, these are in fact rocks which are situated relatively deep below the Earth's surface, where the molten materials can actually cool and solidify, to form these specific type of rocks. Intrusive igneous rocks are in fact stronger and denser than extrusive igneous rocks. Now, extrusive igneous rocks, on the other hand, can in fact be associated with molten materials which cool and solidify on the surface of the earth. All right. To highlight something very distinctively is that intrusive igneous rocks are in fact associated with magma, which is molten materials below the Earth's surface which cool and solidify. For example, the remnants of sills and dikes, they are intrusive features, and the solid rock formation will be associated with intrusive volcanic rocks. Examples of which include diorite, granite, pegmatite, and gabbro, as you can see on the screen here. For extrusive igneous rocks, examples of which can be associated with basalt, andesite, rhyolite, and scoria. All right, students, extrusive igneous rocks are also known as volcanic rocks. All right, look at this image carefully. The molten materials or lava which spews onto the surface, all right, they eventually cool and solidify as time progresses, and this will be associated with volcanic activity. Hence, extrusive igneous rocks are known as volcanic rocks. However, intrusive igneous rocks, for example, if you are talking about these, in fact, molten materials below the surface, perhaps along the vent, or if there is in fact an existing sill or dike below the surface, these are in fact compressed by the bedding planes of rocks. We must also take into consideration these are known as plutonic rocks. So intrusive igneous rocks are termed as plutonic rocks. Keep that in mind for me, all right? All right, for sedimentary rocks, students, sedimentary rocks, the word sedimentary comes from a Latin word sedere. Sedere means to settle. And observe on the screen, you actually have materials which are washed away from the surface of the land, which are called what you call sediments, can actually settle. These fine particulates and whatnot can eventually settle below the seabed, where it becomes compressed. All right. This is a mechanism to which sedimentation is the process by which fine particles are compressed. And this compression over a long period of time form distinctive layers. All right. And these are in fact associated with compressional effect or compaction. And over perhaps hundreds of thousands, even millions of years, all right, these particular sediments can become consolidated into a rock structure. Okay. All right. Let us bear in mind that sedimentary rocks are in fact the most prolific, all right, rocks in the world, the most abundant. All right, students. So look at this particular sketch diagram here, right? This is in fact associated with mechanically formed sedimentary rocks. Now, there are two main categories of sedimentary rocks. We have mechanically formed sedimentary rocks, and we also have organically formed sedimentary rocks. Let us focus first on mechanically formed sedimentary rocks, as you can see on the screen here right now. Now, students, these are in fact distinctive layers, right, of rocks which become compressed over a period of time. All right, the oldest layer would be here at the bottom, and this would in fact be the most, all right, compressed. All right, whereas the surface here would be associated with the least compressed. Now, we should bear in mind that compressional forces are in fact what facilitate the development of sedimentary rocks. The word sedere means to be layered. And as you can see on the screen, there are distinctive layers here, all right, of materials which become compressed over a period of time. And this is important because compression is given by the weight of the surface materials upon existing materials. Now, mechanically formed sedimentary rocks, as you can see here, involve environmental processes such as winds, which can simply blow dust from one location and eventually settle it somewhere else. All right, this dust here can eventually settle, right, on the surface and become compact. In China, there are what you call lowest deposits, and lowest deposits can extend for for large areas, as a matter of fact. On top of that, students, there can also be certain areas where you can actually have the receipt of rainfall, all right, given thunderstorm conditions and whatnot, and the rain can actually wash materials from one distant location to the next and eventually settle them on the surface. These materials can settle over a period of time, and we should bear in mind that these distinctly layers are in fact what we call bedding planes, as we would have seen when we look at when we actually saw the chapter of volcanology, all right, highlighting all these different things. All right, so as time progressed, hundreds of thousands, even millions of years, these materials become compressed. All right, from materials which are perhaps blown in or perhaps washed away from existing areas onto the surface of the land. Two nice examples of mechanically formed sedimentary rocks include sandstone, which are made up of fine unconsolidated materials, very, very fine, whereas mudstone is associated with a little bit of pebbles and larger particulates and other materials which are just basically compressed together. All right, as you could say, mud over a long period of time can become compressed. Okay, so we have sandstone and mudstone. All right, so with respect to organically formed sedimentary rocks, organically formed, all right, this term here will symbolize the fact that these rocks are also very much layered, all right, and we also know fully well that these rocks are in fact created from the remains of um, dead plants as well as dead animals. All right, for example, we can see here they are in fact distinctive layers, which become compressed into strategic layers here. These surface plants can eventually be destroyed and become the surface materials as they decomposed and perhaps be compressed and settled by other materials which perhaps wash over it. Okay, so animals' remains, plants, shells, and whatnot, all of these come together and they are in fact compressed over the years, all right, into distinctive layers to eventually create petroleum, crude oil, fossil fuels, and whatnot. And in many instances, we will extract, right, these particular things to facilitate the industrial activities that we have in the world today. All right, so organically formed sedimentary rocks are created from the remains of dead plants and animals, and over the thousands or hundreds of thousands or even millions of years, they in fact become compressed or consolidated. All right, so this is actually very, very vital. Now, some examples include coal, right? These are in fact coal fragments, which are in fact mined from existing areas. For example, in certain parts of England, they will mine coal, right, for the purpose of fuel. We also have chalk or chalk stone, and we also have limestone, right, which is in fact used in cement production, also as an agricultural supplement, primarily to neutralize the acidity of soils as well, and to increase the permeability and porosity. All right, so sedimentary rocks are very, very useful as well. Now, the third category is in fact metamorphic rock. The word morph means to change. Students, metamorphic rocks are found very, very deep below the Earth's surface where there is immense heat and pressure. Immense heat and immense pressure can be actually fundamental to the point where it can simply alter the characteristics, physical as well as the physiological characteristic of igneous and even sedimentary rocks. So both igneous and sedimentary rocks can be transformed into metamorphic rocks once they're exposed over a period of time under immense heat and pressure, especially deep below the Earth's surface in close proximity to the mantle or in close proximity to the batholith or magma chamber and stuff like that. We also have a few examples, and this is an example of gneiss, right? Gneiss. This is a type of metamorphic rock. All right, look at the distinctive striations on these rocks as well. All right, they are in fact influenced by a lot of heat and a lot of pressure. All right, as you can get these very beautiful patterns and so forth. This type of rock is what you call quartzite. All right, quartz or quartzite is in fact a metamorphic rock. Look at the very distinct crystalline structures embedded within. Okay, and this image here is in fact highlighting graphite. All right, graphite. As you can see, the shiny rock surfaces, which are very dark and very distinctive, as a matter of fact. All right, it's that kind of black shiny surface. This is in fact also associated with a very distinctive amount of heat, right, which could simply create these types of rocks when they eventually cool and solidify. All right, so we have some examples here. So class, I want to bear in mind that the rock cycle, sorry, aims to explain the creation, alteration, and also the destruction of rocks. All right, so I hope this was very beneficial for you all. Be sure to revise your work properly. If there are in fact any questions, you all can feel free to ask. All right, students, have a good one. You all keep safe. Bye-bye.